because clinker is being replaced by supplementary cementitious material like slag and fly ash and many other alternatives, which effectively brings down the clinker consumption, brings down the limestone consumption because limestone reserves are very scarce, may last only 40-50 years if we go at the present pace. Apart from this, in India, since the electricity is produced majorly through thermal plants, we have abundant quality of good quality fly ash also available, which otherwise is an industrial byproduct, but is also a health hazard if not used in the proper way. So cement companies, industry is doing its bit by consuming a lot of reactive fly ash also and producing PPC cement. Steel plants are there which produce product which is of no use to the industry otherwise, but slag is rich in silica as well as lime, can be effectively used in slag cements. So this is also being consumed by the cement industry. So cement industry on the sustainability front is bringing down the limestone consumption by promoting blended cements, is bringing down the carbon dioxide emission by promoting green cements, and consuming lots of industrial waste such as fly ash and slag. And above all, this is a proven fact that uh, uh, concretes, produced with the blended cements like PSC and PPC are far more durable, and if the environment is conducive, may end up, getting more than double the design strength with passage of time. So on the durability front, we are also very active and not taking much time. Now I would request Mr. Chirag Bakshi, and we look forward for his session and hope for such similar collaborations in future also. Thank you, sir, and hope all will enjoy the session.
It was very nice introduction and very good in about cement industry happening in India. Very warm welcome to all the guests sitting in front of. So it is a bit late to say, but then it's a good morning to you. I wish happy day wishes to you. So today we are going to talk about concrete, cement concrete. Concrete, when we talk of first name strikes to my mind is Professor Adam Nabil. Professor Adam has written, he probably first time try to systematize, channelize a good knowledge about concrete. He documented it on a piece of paper, made a book of it, and then gave it to us. When I was studying in civil engineering college between 1975 to 1980, his book was our textbook. That's how we have learned about concrete from Professor Adam Nabil's book. I had to meet him in year 1994 at Hyderabad when he was the chief guest speaker at the So concrete has been a talk of the day, talk of the town, and then since last about 5 odd decades, the concrete has been undergoing a lot of new concepts are generating self-lifting concrete, high performance concrete, and so many things. I heard of late just before some time, few days, I heard that a group in Ahmedabad, a research scholar group in Ahmedabad, is working on zero concrete also. That's wonderful. I mean, people are innovating. Concrete is undergoing a lot of innovation. A lot of the new things are being addressed to concrete to make it more user friendly, more usable for concrete industry. It's a boon to industry. Uh, with these properties of concrete, don't you feel that we also try to protect concrete? We must try to cure concrete if it gets damaged. That is where I'm going to speak today, share my knowledge with you. But before we go further, when we are still on concrete, I would like to precipitated one more word, prefix word, which I have been listening for last few years in concrete. That is sustainable concrete. The Shakun sir just now said about sustainability. So I would like to say about sustainable concrete. What is sustainable concrete? Concrete can be sustainable when all quality factors of material mixing and post construction care are being taken care as per standard manuals. Yeah, that's good. So that makes us the good concrete, quality concrete. But to make it sustainable, uh, uh, I have a few more points to say. Any lapse in these things normally lead to serious consequences and they may concrete perform well. But what makes concrete sustainable? We have seen construction companies making concrete workable and flowable and early strength and delayed strength and few more things. But then we uh, are we yet to see the sustainable parameter for that? I think let us go to next. Sustainability comes according with these things. Alkalinity on concrete must be maintained for a long time, at least up to its curing period, which is normally for 5 years. Alkalinity must be maintained. Concrete has pH 12. So that 12 pH is essential for concrete to perform throughout its function. If alkalinity reduces from 12 to 11, 10.5, the damage has started. Protection is going, sustainability is going. So alkalinity must be maintained. That is very, very essential. Number two, all efforts must be deployed to say bring zero porosity. It's not possible, I know. It's difficult. Zero porosity concrete is yet to come. But social distancing is always maintained. Let us not talk about social distancing. But then zero porosity it tries to achieve. What happens when it is increased, when the compactness increased, a very systematic effort will be there to really reduce porosity, to really bring it down to maximum possible below level. Number three is chloride resistance. Chloride is the biggest enemy of concrete. It has its chemistry of deterioration, chemistry of reacting with ingredients of cement and water and some parts of sand, some parts of coarse aggregates. All these things is very dangerous for concrete. It doesn't give you performance. It reduces the life of concrete. So resistance to chloride must be ensured at base stage, that is up to hardening time of concrete as well as up to hardened stage, 5 years, 10 years down the line, because presence of chloride in concrete even after it hardened is also going to be dangerous. And I've seen its effects even after 5 years, it all of a sudden cropped up and it damages concrete. So chloride resistance must be ensured. Tests available ASTM 4 that can test concrete test back test to ensure that what is the chloride content, the allowable percentage of chloride in that. So that must be ensured. Number four is most important is reinforcement corrosion. We must have seen, we have seen of late for about last, if you summarize events have taken place in last 4 to 5 years, uh, collapse of big. Most of the reasons, most of the failure reasons, reinforcement corrosion. Reinforcement corrosion should be brought to minimum or practically no possibility of corrosion stage. These four things really impart sustainability of your concrete. We want durable concrete. We want to function for all its functional design life of 50 years, 40, or whatever life that we design. For these things these things to really happen, alkalinity must take, zero porosity must be achieved and try to go to zero porosity. Chloride resistance must be ensured, very holistically ensured, and reinforcement corrosion has to be mitigated to minimum. These four things will really get you sustainable concrete. This is all concrete I wanted to tell you. Uh, these factors upon sustainability. But sustainable concrete survives for a long time. But then there are some factors. There are some factors, external factors, which in spite of concrete being made all this alkalinity and porosity and chloride and all those things, there are some natural factors, external factors which have tendency to affect concrete. Concrete has some limitation. They have to be controlled. And for that, we need for the step of this today's presentation, that is protection of concrete. We need to protect concrete from external factors for ensuring that sustainability, ensuring the availability of concrete for this and that concrete. Are the factors which can affect the damage. With exponential growth of chemical, petrochemical pesticides, right, agrochemical, fertilizer, and all those trees, refineries, industries, there is extreme rise, there is steep rise in the use of corrosive environment. Chemicals which are in these industries, they are highly corrosive. They have good affinity to cement and they react with in mix of cement. That is very dangerous. They externally corrode concrete. Had concrete been with zero porosity, probably it would have resisted. The skin would have resisted. But then these things, they have affinity, they have their capacity to penetrate to skin, and they go down to the core, and they finally damage. And these environmental factors, atmosphere is so playing very vital role. I mean, it may not be sounding so significant, but then it has got very uh, on the corrosion, the sustainable, the continuous exposure of concrete members to atmospheric humidity can lead to failure of concrete or can lead to damage of concrete. Third is stagnation. Corrosive liquids, gases, or even solid particles, when they are stagnated over a particular area, it happens sometimes that cleanup is taking time. Liquids are there and there for about 6 hours, 8 hours, 10 hours, or maybe few days. The solid beds are there for few days. Gases are there for few days. If they are stagnated over a particular place, they will find a weakest spot in concrete and they will start penetrating concrete and then they will start corroding concrete. This is very significant and very applicable in the industry. Again, I am coming to chemical industry. They are increasing very rapidly. So there's time. I mean, I just go for them. There are few occasions wherein effluent out of process it cannot be allowed to go to effluent treatment plant because it might carry some nutrients. So that is allowed to that is required stored in the chest and floor and the area by making some temporary curbs and there the stagnation comes. That nutrient value cannot be allowed to go to effluent. Effluent treatment plant will not have those things. Some control boards now they also will restrict. So stagnation will happen. So this stagnation is unavoidable. They will corrode. And similarly, submergence of surface. When surface remains submerged under corrosive environment, corrosive area, corrosive liquid gases, that also can corrode concrete. So these are the few factors which can really corrode concrete. Concrete is very good. It's a very stubborn material. It has been working for construction industry for last two centuries. But then it has inherent limitations. I'll not say defect. It's a limitation. It's a man-made material. It's not like steel, not fiber reinforced thing, or not like polypropylene. That inherent resistance to this, but then it's a made material of simple cement, aggregate, and water. So it has some limitations, and we have to accept concrete is not resistant to this type of corrosion caused by these conditions. So if that happens, what will happen to concrete? Concrete will lose its integrity. It will lose its homogeneity. It will lose strength. It will lose its stability and soundness. The stable and member has got long life, but it will lose it. it will become necessary for the construction. If the proper care is not taken at a proper time, consisting routine, it will need reconstruction again, causing environmental problems and economic conditions. So we have to see that these things are not happening. But then, if concrete is allowed to damage, then these things will happen. Fact of corrosion is that environmental corrosion is easy to control. It is not so severe, but chemical caused by chemicals is very, very severe. It is not possible to control. And so we have to see that quality of concrete, what the ponds with acid seriously, statistically, so that it doesn't get corroded with environmental corrosion. That is a lighter way of corrosion. Now, if we know that concrete is going to be exposed to corrosive conditions, chemicals, corrosive gases and liquids and solids and corrosive environment, and we have a practical design anti-corrosive treatment scheme. How to decide anti-corrosive treatment scheme? Probably people connected to normal person may not have come across this type of. So I would like to go a bit more bit slowly for people to understand this. Selection criteria for materials to resist for resistance to these conditions is the material should be inert because ultimately it has to resist acid attack or alkali attack or chemical attack for concrete. It has to be a soldier protecting the and to fight against the enemy of corrosive chemicals. So the treatment has material has to be thermal and expansion contraction is very important. The concrete is already set, it's already done, there is in position. Environment has different expansion contraction, different temperature conditions. Concrete expand and contract differently. So the thermal expansion coefficient of expansion contraction material to be compatible with concrete. It has to expand and contract with concrete. When concrete will expand differentially and that thing will expand differently, so that they will get debonded. Then third is thermic properties. Normally, acid proofing mortars having acid property are resin-based mortars. Hardener and resin are there. There are two component scheme, three component scheme, and when all components are mixed, they normally end up exothermic reaction. Exothermic reaction it generates heat when they get reacted. And we have seen in cement concrete. When cement concrete is mixed to concrete, when it comes out of the mixture, it is hot. So the reaction between cement and water. Similarly, exothermic property of reaction between ingredients in the resinous material is a bit than what heat is generated in reaction between and water. So that property has to be taken care. Second important thing, compatibility of material. It has to resist the combination of chemicals. If you may not end up facing one chemical, there may be a group of chemicals. There may be combination of chemicals, acid or alkali, or both acid and alkali, or so it is most important. What is that for the strength of materials of motor, strength of the treatment as a whole, comprehensive treatment as a whole, to resist that particular area, that particular attack of acid or corrosive liquid. Economic is very important. It is not necessary. It is not necessary that all expensive things will give a good life and inexpensive things give less life. No, it is. It goes with the requirement, the chemical requirement, the property-wise requirement of the material. And second thing, which I have seen I have always interested in these things and this useful. It is very useful for you also to follow. Always life cycle cost is to be considered. may find the treatment is about 10% costly in initial stage. But if you take a life cycle cost of 5 years, probably that 10% spent early will end up repetition after 5 years. Then 10% saved early may need repetition of treatment every 2 years, 3 years. So in 5 years, you might have repeated that things twice, wherein it's a costly thing would have repeated once. So life cycle cost is very important. Important to selected for treatment. Anyways, life cycle cost I would like to emphasize important that has to be considered very religiously. Second is what is the nature of acid alkali? If there are it is said that alkali at high temperature and acid at low temperature are very extremely corrosive. So in the sulfuric acid at 98%, sulfuric acid at 10%, 10% sulfuric acid will be taken more care rather than 98%. Nitric acid is different case. Alkali at high temperature is different case. They have to be very selectively examined what is the corrosive value of the corrosive liquid or corrosive material to be removed. So corrosive value is important. That has to be done. Uh, Ventilation is very important. I've seen corrosion increasing, accelerating because of no ventilation in a particular. There was a there was a room housing particular chemical reaction process unit, and that was not ventilated. The corrosion rate was very high. I examined the condition. I could find out that okay, the fumes are remaining within inside. It's ventilated. Okay, there was some adequate slope was not provided. So stagnancy, as I said earlier, stagnation was taking place. We provided slope, good slope, and effective draining was there, and corrosive things reduced. So anti-corrosive treatment need not necessarily end up with designing a lining scheme and all these things. Even these conditions, peripheral environment conditions are also important. See that scheme is perfectly effective. There are three basic of anti-corrosive. The most convenient and widely used method is tile stone lining laid in a suitable mortar for bedding and jointing. It's similar to what we do in flooring, house flooring or other flooring, but these are all typical type of things wherein brick or stone is of a particular category, having acid-proofing property, having some IS codal provision. They have to meet the codal provision. Another method, first and most commonly used method is that treatment of this cyclate material. It's premium material. It's almost a liquid, which is a mix of two or three or four. They are mixed in a particular proportion designed by the manufacturer or certified, and they are laid at site and till the job is completed. It is a jointless system. It is and third is factory made sheets. There are few sheets, so many flexible vinyl. These things are made in factory under particular temperature condition under quality control, and they are brought to site uh, and laid at site in a particular process. It's a process to lay the sheet. Now we go one by one. Acid acid proofing treatment with tile and stone. This is only bricks or stones or tile are laid in whichever resist chemical condition. The standards have been separated by Bureau of Indian Standards for physical and other properties of bricks or stones. Even method of laying, how to lay them on a floor, on a drain, on any surface, vertical surface. They have all very specified in BIS, so that should be. Surface preparation is very important. It has to be and a very particular surface. You cannot do with any surface. Humidity should be there. Surface should be dry and clean. Should be sound and safe. should not be having any. There are many and don'ts for surface because that is most important. The say sound surface, properly prepared surface only will receive the good anticorruption and will only support performance of that treatment for a long time. Selection of mortar is important. As I said earlier, mortar to be so that is the heat again. Resinous things will if mortar is consisting of resinous things, then it will generate exotic. So that is very important. That it must be properly taken care of. But it's a particular treatment is definitely advantageous for subordinates, laying, ease of laying, less cost of inventory carrying, cost economics. It's economical treatment. For a lot of advantages. The most disadvantage for this treatment is on joints. Suppose if we want to do this treatment on area wherein we don't want seamless, we want jointless, then this treatment will not be useful for them. And in case of stone, are natural material available from mine. There are few stones specifically having acid-proofing property. The source must be examined very, very precautiously because nowadays, when I was before 20, if I talk about 20 years back, they were getting good stones. They were highly resistant to acid, even severe conditions. But then these days, are not producing those category of stones. So a selection of stone is very important. The mine source must be very important, very selectively used. This is the picture of acid-proof brick line, brick or tile lining. This is the tile. This is the floor. This is the floor. Floor has been the tiles have been laid like this. They were the mortar is kept the backside of tile. Tile is pressed on the and then mortar comes out of the joint. Then joints are filled with the suitable mortar as designed. These are there, and even vertical surface it looks like this. And on this, they are good resistant to acidic conditions. This is what is the brick and tile lining photograph. This is stone lining. This is stone. They are big stones laid again the same pattern and pointing and on stone lining. A pictorial view. Then side plate lining. As I said, resinous lining are there. They are resins, resin hardener, and even catalyst, accelerator. As per the requirement of the site condition, this lining is prepared. Basic resins for this lining are polyester, epoxy, vinyl ester, and the derivatives. They can be modified. They can be modified epoxies, modified and polypermeable at nano level according to chemical resistance that is required of the scheme, and that lining can be laid. Seamless lining, very most important is seamless lining. Uh, the thickness, suppose if we want to thick line, because it will give you 1 mm, 2 mm thickness, but solventless resin. Thickness can be a silica floor or quartz or fiber met to reinforce or to increase thickness of the line. Important. An advantage of this is a jointless lining. It functions very well, but the decision to be taken in this is it should be without any break or break systematically. Maybe when we cast a slab, we give a joint. If required, a joint is given around beam so that the load transfer is not affected. These things that normally have expansion contraction properties in a very different way. So they have to systematically design. If a break is big, it has a systematic design and plan. Exothermic heat, as I said earlier, exothermic heat is very important because when they are mixed, then that point itself it starts emitting. So that heat compensation is very important. So it has to be managed properly. This is cyclade, resin, and I am showing next. Resin was mixed, resin hydrobase mixed. This is a clean room, a laboratory room, wherein you needed uh, stainless lining. So this was done in that area. Second is same lining, same epoxy lining in done in effluent carrying tank, effluent storage tank, wherein effluent was to be stored in tank, and this tank, this concrete surface was not capable enough to resist those chemicals that has been properly. This is the thick lining, and this is how it is laid. Person is putting that resin and then spreading. So this is how it is laid like that. Third is sheet lining. I will not talk much about it. Their sheets are manufactured in factory. They are as per the instructions, everything as per the requirement. They are brought to site and they are laid at site. The joint is very important. The perfect adhesion has to be there because again expansion contraction factor is coming into play. And then again sheets have a tendency to get up like and to stay steady. So seed should not get up like this. So for that addition is very important. There is a systematic method laid down in BIS, specific IS code. So that should be followed. The code which I have written for PPGL, that is addition is very important. Even similar way should be done. We can talk in at length at some other time, but then it is enough for this presentation. In spite of all this, in spite of all protection measures, in spite of all care, sustainable concrete, in spite of all these things, concrete got damaged. Suppose concrete did not perform. Any failed somewhere because of mechanical failure, because of some or other failure. Then what the concrete member has to perform. The member has to be available till its functional life. So the care has to be taken. The next comes to care, protection and care. What is care? Care is I don't mean cure by curing that water. I don't mean cure. Cure or rehabilitate the damaged member. So the damaged member has to be rehabilitated properly, and so now protection is over. Unfortunately, if protection did not work, unfortunately concrete failed from somewhere. How to rehabilitate? Once concrete is identified for unforming, like there may be cracks, there will be solid concrete explorations, skeleton, honeycomb effect, reinforcement exposure, and then we study so many things, so many things. So then it has to be assessed scientifically, and results have to be comprehensively. I repeat, it has to be comprehensively and appropriately analyzed. This is important. Talk about it further, but let me spend 1 minute with that. We all must have undergone some this if we have some malaria or some fever or some other sickness. What do they do? Doctor, what will say? No, no, only the HP will not work. Let's go for ESR, let's go for UVC, let's go for RBC, let's go for SCPT, and here's comprehensive view. I think HP is okay, ESR is not okay. So I think you have some infection. No, no, WB is okay. He'll have comprehensive, evaluation of that blood. He'll also do report by side by. He'll also sputum stool reported. So many things, right? Similarly, similarly, damaged concrete has to be comprehensively evaluated. There are many methods available, NDT available, destructive methods available to assess, find out the values of damage. 2.5 and 5.3, you'll get those values, but they will be correlated and comprehensive analysis of NDT results is very, very, very important. I'll insist on that. Yeah. When damaged concrete is to be tested, NDT methods are preferred over destructive methods because it's mainly because concrete already damaged. and then you go some core cutting, and then you go for some chiseling and take it down to sample. I think we avoid it as far as possible. You should try to restrict to NDT methods, just to uh, just to reach whatever strength has within. These are few NDT methods. Rebound hammer test. We all must be knowing all these things. Rebound hammer test, USPV test, proton pulse velocity, carbon test, Household potentiometer test, chemical analysis test. There are few, but they are done in a very precise way. These are not commonly used tests for evaluating the underperforming structures, concrete structures, right? Uh, I will, yeah. Results of, as I said earlier, comprehensive analysis. If you cannot just rely on our test and diagnose, okay, this company is bad, those can X and Y. USPV has to be done, carbonation has to be done, absolute potentiometer for enforcement has to be done. All those things have to be comprehensive. I like and here, if result about test is good, but USPV is bad, what to do? Rebound hammer will give you idea about skin of concrete. Ultrasonic will give you idea of a core of it. So skin is good in this case. Skin is good, but core is bad. Probably that was some not good construction practices, or maybe some chemical things, or some X and Y reasons. The treatment for rehabilitating the member will be different in this case. If both were bad, treatment would have been different. If both are good and some third thing would happen, it would be different. So it has to be, you cannot just rely on rebound hammer test or USPV test or carbonation test or X and Y, right? It is essential and mandatory that test the structure should be identified. Yeah, it is very important. If we go for chemical effects, there is some the concrete to chemical area. Treating the skin may not be adequate, may not be enough. The core has to be tested, and if core is bad, then injection grouting. Anyway, we'll come to that later on. In which condition the member has been damaged? In which condition member lost its strength and the durability? So those conditions have to be conducive selection of NDT. That is very possible. NDT has got huge bearing. NDT has to be done very systematically, scientifically, selected systematically, and that is how it will give you an idea about structural rehabilitation scheme, and coefficient has to be taken result so that it doesn't get damaged once again the back root cause of damage. NDT analysis gives an idea of root cause of damage. We want to arrive at root cause of damage. It was chemical, bad construction practice, some external effect, rigidity, or the reinforcement, or poor ingredients. I mean, there may be n number of reasons, but with comprehensive analysis of entity, the root cause, and that will give you idea about how to systematically and how to design of the structure. Right? These are don't get panic. The columns which you are looking in front of you carries 80 tons on it. So the equipment has been stopped, but you can see what is the condition. How serious these damages are. Uh, Pictures are going to be still more worse than this. And I was connected with the rehabilitation of all these things, for which pictures I'm going to show you now. But you can see what extent of damage it can happen. You can see on left side, the reinforcement bars have been opened out, skin has gone. You can see on the right side, the columns have been cracked, and skin is going to go away, core count is going to go away. I don't know about the core concrete. NTD was done, core concrete was also found bad, and then it was. You can see this is a column base. You can see the crack pattern. The crack pattern on left is a crack. It shows that there might have been some ingrace, some construction material on skin also has been eroded. On the right side, you can see the dimension. It is absolutely unhealthy condition for any concrete. Can you see the cover portion below reinforcement in being? It has gone. It has very badly affected area in a chemical industry and really serious. On your left side is a water tank. Somehow 40% height from bottom has been badly affected. But this water tank needs to be taken out. But then some temporary scheme was required just to sustain for few months. So we have given that scheme. But this is, you can see the damage, lack of damage. This is falling off. On your right is a tank foundation. Columns have been cracked. This goes to saline conditions as well as chemical conditions. Both conditions have affect the column base. You can see the crack column, and these cracks are not normal cracks, they are serious cracks. Now, can you see left side? Why did I put this picture? On your left side, you find a fairly good surface. It is not having any no polish, no exposure of it, nothing. But then, do you see? Do you see? Maybe can you see here? Can you see here? This is orange pattern. This is orange patch. What is this? This is reinforcement corrosion. Corroded reinforcement has started coming out from this construction joint, and that is how it gives an idea that reinforcement has started corroding, and tomorrow it may expand its volume, and tomorrow it starts scaling from here. Same thing is here. You can see here, see here. All these things you can see. Uh, these are all weak points in a particular tank. Okay. Here on the left side is a concrete fail at bottom. On right side again, effluent is coming from this joint. Now this effluent storage tank. Effluent is coming from this joint, and you can what it will catch and what would be happening at this point. Can you imagine what would be happening at this point? I don't know whether when you open out, when you empty out the tank and open out, I do not know what will be condition of this particular area. Sorry, see, this is a area where very important equipment is supported over this. You can see beam skin reinforcement is gone. The skin has gone, reinforcement is exposed. You can see even by side of it, even the slab is same thing, different view is exposed. You can see how bad it is. This will go because efflorescence has started. This will go, yeah. And now which are going to see, please. It's a real picture. It is not a animated, but you will be to see this picture. Are you shocked? This reinforcement bar, diameter of this bar was 25 millimeter, and you can see how much it has reduced. The person behind the bar helmet, and you can see, and above this is a filter, chemical industry. One filter is there, back filter is there. The filter is running. It is I won't be able to name the chemical because it's not permitted. But this chemical is more corrosive value than explosive value. That corrosion is spoiled. It has removed the beam, and the equipment is running on that. So these are the few of the damage. Those structural steel is part of this topic, but then to tell you how bad also can be affected. I just wanted to show photograph with you. You can see these particulars. You can see. Can you see this? This is the real damage caused structural steel member column, and this is under load. You can see this column. How bad it has gone. How bad it has gone. Even the top skin has gone. Not only painting. Painting has gone, different thing. But then even steel layers, one or two few layers have gone. Same condition, structural steel. How much can you see boil and chemical effects and how much it has damaged? What would be integrity? When I went to see this structure, I was told that its buildability also. If you try to put a small text on this, it will not sustain. It will not take. So now let us come to basic principle. How to rehabilitate? I have to go a bit fast now. Fresh mask. These are few important principles on which we have to rehab scheme. Mask for rehab has to be identical as like mother structure. Thermodynamic density of fresh mass and material should mother structure is weak and fresh mass is high density or other way. That will not be compatible. That scheme will not last for a more time. New mass should not become. This is very important. People say, ये पैच लगा दो, ये पैच लगा दो ना. That patch will not work. The patch mass load has to go right up to the bottom, right up to this stuff. Because fresh mass already weak. Now you are putting some extra burden on it and expect reinforcement or the other remaining take load of that. That is so it has to go on the foundation. That's what I suggest to go. High density rehab can minimize surface porosity, but it should not be so high that it should affect the structure of original area. No? Selection of material. Now material has to be also selectively used for this. They should be compatible with physical properties, chemical compatibility, because if it has been because of chemical environment, chemical effects, then it has to be also chemically compatible. It has the external surface environment that also be there. Exothermic reaction. I have always seen, you must have observed, I have been insisting on exothermic reaction, exothermic behavior, because I have seen that effect right throughout my career. It has been ignored area, but that exothermic thing cannot be forgotten. Its spotlight, consumption pattern, all these things are very important for any subsequent chemical for selection criteria. No? High pressure injection are definitely very good things critically, but they have to be critical. Why? Because if they are not done under calculated pressure, then what they will do, if your pressure is high, they'll aggravate internal crevices and the structure. If it is low, they will not travel to crevices and they will stop in between and just get set and leave the crevices behind unattended. So crevices will be finally filled up. But then high pressure injection system has to be very holistically calculated. It has, pressure has to be calculated, viscosity has to be calculated, the crevice area has to be calculated, so that by the USBB test and other tests, so that it's a systematic thing. Structure protected externally should be protected externally, because we have seen in earlier area that protection is so you may repair structure with high grade material, high grade system, but then if you cannot protect externally, you made it stand from internally, but externally also it has to be equally protected. Let it be sacrificial coating, let it be repeated every 2 years or 1 year, but then it must be protected so that the repair performs. It performs in a environment where it is desired to perform. Safety is most important. The scheme must be very safe. I have seen one of the accident sites. I was involved in that site. The accident took place. A portal structure damaged. Portal structure was so bad that the top members have to be dismantled. So those things they were not. But as the structure was damaged and we could not continue with portal structure, we had to make it to simply supported structure. So those things. So again, working at height came into picture, and again safety came into picture. So that is very important. As I said here, that safety is also like resin harder mixing ratio sequence is very important. Resin harder has to be with the resin has to be there and hardness has to be put inside. It should not be harder than resins put inside. If you put it, there will be explosion. So safety is very most important. Safety must be ensured properly. Stability is very important. You are repairing member and the sidebar member should not be affected. It should be taken care that while taking a member for repair, if you are ignorantly taking away support of the adjoining member, you are inviting one more collapse. You are inviting the instability, imposing instability. So philosophy sensitive have to be very carefully examined before finalizing and making the rehab scheme. And production, every rehab activity generates dust because there is some this one demolition, there is some chipping involved, and some debris will be generated. So those have to systematically. Environment should not get affected, and if those debris, if those chipping material, they carry chemicals, they have to be again more systematically disposed. Pollution problems are not happening. You are trying to rehabilitate something not at the cost of environment. No. Economy, again, important. Everything ultimately comes down to ultimately it comes down to budgeting. And I said in previous part, I repeat in this, all technically excellent schemes are not necessarily great and vice versa. There are these days, schemes are available like fiber are available, laminates are available. So there are many things. People go for things, but then, अरे भाई आपका grouting से हो जाएगा fiber कर देगा. So like economy has to be because ultimately it will use of available resources must be so selectively used so that they are available right through a scheme. Suppose if you are rehabilitating a commercial complex or industrial complex wherein you need 500 bags of your repair mass, then you end up अरे यार 300 बैग का नहीं मिलेगा अभी तो. Then you are gone. You have substitute for the 200 remaining bags. So you have to ensure that locally available, available, and if preferred locally available material. It should be in your hand, should be under control. So use of available resources must be explored. That's all from me. Concrete is a delicate material that's handled with love and care, and I hope I tried my best to share my applied knowledge, and I hope it should be useful at one or the other stage of your life, of your professional career. And let us be a soldier to protect. Concrete is a delicate material, very important delicate material with love and care. That's all I had to say. Before I end, as I do normally, we'll have national anthem. I'll stand up from my chair. I will expect you. Please stand up on your chair, and let join me with the national anthem. जनगण अधिनायक जय भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्रविड़ उत्कल बंग विजय चल यमुना गंगा चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाए तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय जय हे जय हे जय 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 हे. Thank you.
Thank you, Chirag sir.
Uh, Thank you.
Thank you for such a wonderful session, and I hope we all have enjoyed it thoroughly. And the last line that the concrete is a delicate material. Let us handle it with love and care. Is beautifully written, sir. And closing the session by national anthem, all felt the our patriotic feelings. So before closing the session, sir, there are, I think, few questions. So we'll take up. One of it is from Mr. Lee. He is asking, is there any novel method on ASR mitigation if reactive aggregates are present? So can you clarify, oh, Chirag sir?
AA mitigation.
ASR
There
mitigation.
are, yeah. ASR mitigation, yes, it is being addressed these days. There are very specific construction chemicals for this. I don't remember right now, but there is a method to do it. And in one of my cases at site, ASR was addressed, but can the your voice was not, yours it was breaking in between. So can the participant contact me on my email? There in the slide, even I can share this very simple omchirag@gmail.com. You can share with me, and I'll definitely share whatever solution is present for that.
Right. Thank you, sir.
Yeah,
I'll request other participants also, if they want to ask anything, they can post their questions. I'll ask that question. Probably, I think nobody is asking any question, Chirag sir. So I will once
yeah.
again thank Chirag sir and all the participants who have spared their valuable time for this technical session, and we will try to organize such session in coming days once again with Chirag sir only. Chirag sir, we will do a session on your uh, approved patent, how to make concrete with seawater, and very soon, so in next 30-40 odd days, probably January end or in the beginning of February 2021, we'll have a 1 hour session on this exclusive topic, and we will
I'll
expect
be
more and more people to join. Yes
I'll
sir.
be happy to share all knowledge with a very august audience and on a very, very, very nice platform, JK Cement. Uh, I also express heartfelt gratitude to Dasji first to start with, the Vikas is sitting in front of me, and the whole team, whole management of JK Cement. So kindly give me pleasure for sharing my knowledge. Thank you so much, and it was wonderful experience for me. Probably I got a bit more excited when I was talking because I'm so passionate about what I did and sharing my knowledge. So thank you again. Thank you so much, Siddharji, giving me opportunity to
Thank you.
share that.
Thank you. All right. Thank you very much. Thank you everyone.
Thank you.
Thank you.